Today we're going to start our training course on specialized financial modeling, complete aspects of solar PV plant. Okay, so this is the syllabus that we're going to complete one by one, and in a duration of 15 days. Today we're going to start with the solar installations and various component and specifications unit produced particular topics. Okay, so in solar financial modeling, first of all you have to know the technical aspect with respect to the energy generation. So that is the motto to start with the topics of solar insolation, various components, specification, efficiency and unit produced. And also you should be knowing the various derating factors, or we can say PV losses in a particular power plant. Okay, with the help of that only you can able to know about the total energy generations, and then you can develop a financial model on that. So a particular financial modeler should know about this much technical points in solar, or we can say this the technical part with respect to energy generation. Okay, so first topic is about the solar insolation. So solar insolation is basically we can say it is solar power. It is also sometimes called as solar radiation. Now solar insolation, solar power, solar radiations are all the same topic, is concentrated with respect to solar power only. Now let's talk about the unit of measurements. So for measuring solar power, we use the unit kilowatt per meter square per day. Now instead of day, you can take here with respect to months or with respect to year. Okay, anything you can take as per your convenience or as per the requirement. Please note the writing notation of writing kilowatt. The K should be small and W should be in capital. It should not be like this. This is a wrong notation standard in solar. Now this is the first thing. Second thing is solar irradiation. The solar irradiation is also called as solar energy. It is also called as GHI, right? Or we can say it is a short form. So the full form is global horizontal irradiation. Sometimes it is also called as global irradiation. Okay, so both of this is denoting in a simple word solar energy. Now let's talk about the unit of measurement. It is K in small WH per meter square per day. Now this can be a month or a year, any time interval you can use on your convenience. Now what do you mean by kilowatt per meter square? So it is total solar power coming from the sun on 1 meter square area of land. Similarly kWh, total solar energy coming from sun on 1 meter square of land. Now what is the difference between solar power and solar energy? So both are with respect to electrical thing, but power, difference in power and energy is, what is power? Power is whatever is the sun, whatever power coming from the sun we are getting, okay, in terms of solar rays, right? So it is whenever we are not attaching the time interval with power, it doesn't become energy. Okay, so for a very simple example is in our home we consume power, okay, like 1 kilowatt, 2 kilowatt. But when this consumption is measured over time interval of 1 month, it becomes energy. So that's why we get electricity bills in terms of energy unit consumed. Okay, so power is capacity to do work. Okay, so here power consumption happens by power consumption is happening in our home, and which things are consuming the power? Our electrical appliances. Now for what duration it is consuming the power? It becomes energy. Okay, so similarly solar power is coming from the sun, and for what, if we are connecting the time interval like in a day, in a month, in a year, so it becomes, when we attach the time factor in it, so it becomes energy, right? So that's why in kWh you can see the hour term is connected to it, right? So rest was only same, but hour term is connected to it, that is a time factor. Now we will talk about solar irradiation in detail. Solar irradiation is also called as GHI. So in solar field, the technical term used for solar irradiation is GHI, that is global horizontal irradiation. Now what is GHI? GHI is total sun radiation, solar radiation which are coming from the sun over that over the surface of earth, right? Now this GHI is further, we can say it is divided into two parts. One is called as DNI, second is called as EHI. Now further, DHI is having one more sun radiation, solar radiation category called as albedo. Now full form of DNI is direct normal irradiation. Full form of DHI is diffused horizontal irradiation. Now let's talk about one by one. What is DNI and what is DHI? So DNI is direct normal irradiation. Now we're going to understand this thing by a very simple figure. Let's suppose this is a building roof. Let's suppose here there is another building. This is 1, it is 2. Let's suppose we can make some other objects like trees, so that we can get a more practical view. And this is our sun. Now let's suppose we have mounted a solar panel over this roof. Now what is DNI? So DNI is direct normal irradiation, is those part of GHI, that is total sun irradiation, which are coming on the surface of the solar panel directly, that is without any reflection from the other object like trees, any other building, or without any transmission from any other object. It should be coming directly. That is the first characteristics. Second characteristics is it should hit the solar panel surface at 90-degree angles. Now let's see how. So the solar rays will come like this. This is how solar rays will come, and when we see on the microscopic point of view, they are exactly coming like this. Making an angle of 90 degrees. So there are two characteristics about DNI. One, they are directly coming on the surface of solar panel. Secondly, they are at 90 degree, right? Means normal to the solar panel surface, right? So these type of sun radiations or solar irradiations are called as DNI. That means direct normal irradiations. The word itself says direct. Normal means at 90 degrees. Irradiation means solar irradiations, right? Now, let's understand about DHI. This is our solar panel. Now DHI sun rays will not be coming directly, nor they are hitting the solar panel surface at 90 degree, but they are actually diffuse sun rays, or they are reflected from any other object like building or trees. Then they are coming on the solar panel surface, or they are diffused. So anything but not a case of direct. Okay, so it can be shown like this. So this can be a case where they are directly coming, but the second condition is not happening. That means at 90 degree angle they are not hitting. They are hitting at an angle but not 90 degree. That's why they are not in the category of DNI. Okay, but they are coming directly. So for becoming DNI, they should having both of the things. That means directly coming plus 90 degree hitting angle, right? So this rays are DHI only, diffuse rays. Secondly, rays like this, so these rays are coming from the sun, then got reflected from the objects like trees, buildings, and then coming on the solar surface. Okay, so these are also under DHI. Then now these rays which are coming from the sun, first hitting the surface of the roof on which the solar panel is there. Right now it is a roof. Otherwise, if solar panel is mounted on the ground, or if it is a ground mounted project, then the surface will be ground. So the solar irradiations which are hitting the ground first or the roof first, then coming on the solar panel surface, are also under DHI rays. Okay, but in DHI there is one category we can see called as albedo. So albedo, so these rays which are actually first hitting the ground or the roof, then coming on the solar panel surface, those rays only are especially under category of albedo, and albedo is under DHI only, right? So these are this is the concept of DHI and albedo. Now, Now let's talk about types of solar power plant. Now there are three types of solar power plants which you can see in the solar market. First is called as grid connected, or grid tied solar power plant. Okay. Second is off grid solar power plant. Third is hybrid solar power plant. So these are the major three categories in the solar market which we are going to study the financial modeling about. Okay. Grid tie solar power plant. Now in grid tied solar power plant, the first thing you have to know that grid line, or we can say it is the power utility line, nearest power utility line, is compulsion to connect with the solar power plant. It is a compulsion to the solar power plant for its operation. Without this line, if it is not be there, then that is not be a grid tied power plant. It will be an off grid case. Okay, so for its operation, grid line is definitely there. If grid line is not there, then we have to provide this grid line replacement. Replacement can be done by a AC generator of equivalent power. Okay, so this is the replacement if grid line is not available. Okay, now why this is needed? Grid line is needed. Why this is needed? So for this we have to understand the architecture of the grid solar power plant. So by a block diagram we can understand this thing. So this is a block diagram of a solar panels. It is going to your grid inverter, then it is going to your load. Now here we are having a power utility line coming. Now first reason to connect the power line, that is, let's talk about the reasons. Why? First reason to connect the power utility line is during reason for grid or generator connection. First reason is after sunset, grid inverter needs grid power for delivering to the load for load operation, for load power supply, right? So that means during sunrise, grid connected solar power plant will only work from sunrise to sunset whenever solar power is there. After sunset, grid, no solar power will be there, so there should be an alternate power, so that will be full-fledged from the power utility line. Second, during rainy seasons, balance of power will be fulfilled by the grid line. What this means? During the rainy seasons, when solar panel is not enough, solar power is not enough to fulfill the load demand, then balance of the power will be fulfilled by the power utility line. For example, let's suppose a 10 kilowatt solar grid tied solar power plant is installed on a roof of a house, and 10 kilowatt is the load requirement. So in summer it will be well fulfilled by the solar panel because sunlight is good. But in rainy seasons, solar panel have shows some reduction in solar power, not totally. In rainy seasons also solar panel will able to generate the power, but not exactly same as the summer seasons. Okay, so there will be a slight decrease in the power graph, right? So it depends on the quality of solar panel and how much is the solar radiation available during the rainy season time. So it depends on as much as solar radiation is available during the rainy season, your solar panel will produce the power accordingly. Okay, so but in rainy season our difference power reduction is always there. So definitely let's suppose in rainy season our solar panel is only producing 5 kilowatt power and our load one is 10 kilowatts, so rest of the power will be taken by the power utility line, that is 5 kilowatt. So grid inverter is a very sensing device. It is the brain of the solar power plant, so it always take care or observe the solar panel productions plus the power utility line power coming from the utility line plus also the load demand. So whenever any power difference is there from the solar panel, solar inverter takes the balance of the power from the power utility line and fulfills the demand. So in this case 5 kilowatt from the solar panel and 5 kilowatt from the power utility line, inverter will fulfill the load. So 5 kilowatt from here and 5 kilowatt from here, 10 kilowatt will be fulfilled like this. So balance of power, for balancing the power grid line is required. Now third is grid for the start of, for starting the for the grid inverter to start up at every sunrise, it needs the process called as synchronization. Okay, so synchronization means that sensing of the voltage and frequency and phase of the power utility line, not taking the power but only the sensing of the power is there, so that inverter can able to start up and start generating the solar power. Okay, so for the synchronization process to happen, the voltage, frequency and the phase of the power utility line and the load side consumption demand, that is the load side voltage demand, frequency demand, and the phase demand should be same, and same thing should be provided by the solar panel also. So these voltage, frequency, and the phase should be matched up, should be same on the solar panel side also, should be same on the power utility side also, should be same on the load side also. Okay, so once this happens, synchronization process take place, due to which inverter can able to sense these three factors, voltage, frequency, and the phase from the load side, and then it start at the sunrise. So for synchronization it is required. Okay, so these are the three things so that our grid inverter depends upon for a successful operation of the grid tied solar power plant. Now let's suppose if grid utility is not there, then you can also connect instead of this thing a generator. Okay, so whatever voltage, frequency, and phase the inverter is sensing from the power line, same should be produced by the generator. So the generator, so that synchronization should happen. Okay, now but when you connect the generator, so the power rating of the generator should be 3 times greater than the capacity of the solar power plant which is installed. Okay, so this is the thumb rule. Power rating should be 3 times of solar power plant capacity. It is a thumb rule, and we can also say this is a requirement when you want to connect a generator instead of power utility line. Let's suppose in a place where power utility line is not available, and in that place you want to install grid type solar power plant, so this should be the requirement. Now what is another condition, another scenario, that in a place grid is available but grid power is not coming throughout the day. Okay, so first of all, grid tied solar power plant is only installed at a place where 24 hours grid tied grid power is available to the client, and client is fed up of high electrical bill and they want to save their bill. So this type of solar power plant can fulfill their needs, so you should be pitching this type of solar power plant to them. Second type of requirement comes in a scenario of a place with grid power available but not available throughout the day, load shedding is happening. So for that duration, when load shedding is there, so in that case you can connect. So in this category we will having a power line also like this, power utility line. So in this scenario where load shedding is there, then we have to install if you are installing grid tied power plant, then you have to connect both of the line, that is power utility line also, generator also. Now how it will going to work? Whenever inverter will sense no power coming from the power utility line, that is during load shedding, then generator will get start up by a auto starter connected with it, and generator will start feeding the inverter. Okay, so this is how you can also able to pitch grid tied solar inverter in a place where 24-hour grid availability is not there, but for some hour it is available, for some it is not available. But maximum client market which are in need of grid tied solar power plant is basically those who are fed up with their electricity bill and are having 24-hour grid available at that area. So this is all about grid tied solar power plant. Next, in the next class, we're going to study about the technical parameters, some of the technical parameters of solar panels, grid inverters that you should know as a financial modeler.